Welcome you all in this new video, and in this video we are going to derive the expression for wave function, okay, for a particle that is moving inside the box, means one dimensional, okay, one dimensional, that is. So if you remember, in the previous video we discussed about the one dimensional particle in the box, okay, means there is a particle in a box, okay, and we derive the expression for energy there, okay. So actually in this video we are going to derive the expression for wave function. Wave function means that when that particle is moving inside that box, okay. So what is the character of that wave that is associated with that particle while it is moving in the box, okay, of particular length, okay. So let's derive that what is the equation for wave function, okay, what is that wave function, okay. So let's first remind something about the previous video, okay. You see that there we consider a box, okay, let this is your box, and this box is of length L, okay, we consider that, and we apply the Schrodinger time independent, okay, wave equation. We apply this equation there, okay, and we get the conclusion of energy of that particle, okay, En, that is En was n square h cross square, okay, and pi square over 2ml square, okay. L is the length, or you can see the width of that region, okay, in which the particle is moving in one dimensional, okay. So in the process to calculate or to derive this expression for energy, we get a equation in the middle of this process, okay, that was this: phi x is equal to c sine k x, okay. So this is the expression that we get in the middle of this process while we are going to calculate the energy for that particle, okay, that is moving inside this box, okay. So c is the amplitude. So this is the equation that we have to modify to complete sense, okay. Why? Because c, we don't know what is this c, we replace it by 2ia, but it is not the correct value, okay. I means iota, it gives the imaginary value, so we have to derive the actual value for c, okay. So by deriving or the actual value for c, then we will put in this expression, okay. So that's why we get the complete and accurate wave function expression for this particle motion, okay, wave character, okay, that is associated with the particle that is moving inside that box, okay. So let's start our video, okay. So what was the expression that we have? That is this c sine k x, okay. We know what is the value of k, that is n pi l, okay. This is the expression that we get from boundary condition, okay, while we was calculating the expression for energy. In applying boundary condition, we get this value, okay, by replacing the value of k through this value. So we get sine, okay, n pi x over l, okay. This is the expression for wave function, okay. Now we have to calculate the value of c, because till we don't know what is the value of c, okay. So how we are going to calculate that thing? We will use the normalization constant, okay. Normalization condition कह सकते हैं आप. Condition. What is the normalization condition? Means what is the total space here? Total space is 0 to L. It means that in the region from 0 to L, okay, the probability of finding that particle inside the box, okay, that is 1 unity. Means you have to integrate the probability, okay, probability density, that is what? That is product of delta x, psi x over complex conjugate of psi x, okay. You have what is the normalization constant? Means probability density, okay, inside the box, okay, in the region from what 0 to L is equal to 1. So by applying this condition, okay, by normalization condition, we will easily get the value of c, okay. Now let's apply how we are going to do this thing. So first of all, let's write what is the wave function that we have, okay, sine n pi x over L, okay, by normalization constant, by normalization, okay. You are applying the normalization condition here. What is the normalization condition? From 0 to L, this is the total region, okay, that a particular box have, and we have to find the particle within this range, okay. So del psi x, psi complex conjugate of psi x dx is equal to 1. okay, by putting the value of these two in by through this value, okay, so we get c square, we take this common, okay, 0 L, and inside we get sine square n pi x over L dx, because you are dx, we had considered here dx because the particle is moving along the x axis, okay, in a box in the one dimensional. In one dimensional means either it will be x, y, z, but once it will be along only one axis, okay. So this is the equation that we get. So by doing this further, we get you know that sine square x, you can write this like sine 1 minus cos 2x, okay, you can write this thing like this. So by applying that thing here, 1 minus cos 2 n pi x over L dx is equal to 1, okay. Now solve further this equation that we get this, okay, 0 to L, okay, and here is inside dx minus 0 to L, what is inside cos 2 n pi x over L dx is equal to 1, okay. So this term will be totally equal to 0, okay. So by replacing this term from 0, okay, so this will be neglected, so we get the expression 0 to L, okay, this is the integration, okay, you are finding that particle in this range 0 to L, okay, that L is the length of that whole box, okay, is equal to 1, okay. So now doing further this thing, what we get, c square, okay, this is as it is, as inside what you get, okay. So one thing you have seen that what is missing here, that is 1 over 2, okay, there should be 2, here should be 2 like this, okay, 1 over 2, because we missed one thing, sine square x is equal to 1 over 2, 1 minus cos x, means sine square x is equal to 1 over 2, 1 minus cos 2x, that's why we get here 2, okay. Now doing further this, here we get only L because second term is 0, so this will be c square is equal to, sorry, here is 1, okay, 2 over L, okay. And what is the value of c that we have, that we get in the final expression, that is this under root 2 over L, okay, 2 over L. What is this L? L is the length of that box, okay, in which that particle is present, this. So by replacing this value from that expression, okay, what was that expression, psi x is equal to c sine n pi x over L, okay, by replacing the value of c in this expression, so we get the final expression, okay, final expression for the wave function in when a particle is moving inside a box, okay, in one dimensional. So this is the expression that we get, 2 over L, okay, sine n pi x over L. This is the final expression that we want to derive, okay. This is the wave function, this represents wave function of a particle, okay, that is moving inside the box, okay. So we know that when a particle is moving inside the box, so there is the energy that we had already calculated in the previous video, okay. So there is also a wave character. Through this wave function we represent that wave character, okay, which kind of wave character that have, okay, what will be the amplitude, etc., okay. So I hope you like this video. If you like our video, then give a thumbs up and do subscribe our channel. Wait a minute.